Hi, Tatu. Morning, can you hear me? Morning, Tatu.
It's actually starting at 12.
Yeah, but you feel choose starting at 1.
Yeah, like I interact with the teacher.
Oh, it's like one-on-one.
Yeah.
So like 2-3. So you have a tutor.
Yeah. Mariang sharp on med still. Yeah,
Is he nice?
yeah. He good. He good. I don't want to lie.
Okay, Tatu, when you're ready, you can unmute yourself. Welcome to the class, Tatu. You just need to unmute yourself.
Hello, sir.
Morning.
How are you?
Okay, where are we at the moment? We did some click
Yes.
graphs last week or last time.
Yes, sir. Sir, today could you please work on the assignment?
Yes, I can. Remember, I'm not always sure if I'm allowed to.
Yeah, Auntie D just told me now that I should ask you to work on it with me.
Okay. Do we have it somewhere?
I have it on my phone, but Auntie D said she sent it to you via email.
On WhatsApp or on email?
Check on both sides, sir, because I think she sent me either on email or on WhatsApp. I'm not entirely sure.
Okay, I'll check on both. Can't see it on WhatsApp. Right, just give me a second. No, I don't see it, Tatu. I get a lot of, oh, there we go. I get a lot of emails and stuff. I'm not always 100% sure where they are, but I've got it here now. I'm just going to open it. Okay. Let me just put it on the one side, and I'm just going to paste some of the questions in.
Okay.
Right. So we're going to call this assignment.
Double S.
Right. The first question is on graphs. Do you have the assignment in front of you or not?
It's on my phone. Let me just open it up.
Okay, fine. You don't have to watch it on your phone. You can just look at it. Yeah. Can you see it actually?
Okay. Yes, sir.
Okay. I just need to be able to move it. There we go. Okay. There's two graphs. F, that's a straight line, and G, which is a parabola.
Yeah.
Okay. If I make it smaller like this, can you still see?
Yes, sir.
Okay. The first question, 1.1, is they want you to write that G, the graph, negative 2x squared plus 4x plus 6. They want you to convert that and write it into the form gx equals ax minus b squared plus q. And there are two ways of doing it. One is completing the square, which I would not advise. And the other one is just by getting the turning point of that graph. Okay, can you see the a value?
Yes, sir.
A is what?
-2.
-2. Okay. Now, the p value is the turning point, the x value of the turning point. And then you can get by doing negative b over 2a.
Yes, sir.
So that's -4, which is b, over 2 times -2. And that's 1.
Yes, sir.
And you can get the y value of the turning point by substituting 1 in. So there's a specific way that you write it. You write it like this. G of 1. And that is -2. And instead of an x, you write a 2 plus 4, 1 plus 4 plus 6. And then you put that in your calculator. You should get 8. Let's just double check that.
8.
8.
Sir.
Okay.
Yes, sir.
So now I have A as -2, P as 1, and Q as 8. So the graph is gx, or g of x, -2 bracket x minus 1 squared plus 8. That's easier than completing the square. Would you be able to complete the square?
Yes, sir.
Okay. So we could have done that as well, but that's stuck. Slightly easier. Right. Do you want to photograph that?
I've already wrote it down, so.
Good. I'm just going to keep this separate, and I'm going to wipe that screen.
Yes, sir.
Right, 7 marks. Wow. Draw both graphs on the same set of axes and show me the points of intersection. So let's get a system of axes going. Oh, this is like an ugly green. Let's just make it brown. There we go. There's my system of axes. Right, the first thing we need to, well, let's draw the straight line. F first, make that red. F is y equals 2x minus 6. So I know the y-intercept is like, what, -6.
Yes, sir.
Okay, I make y 0 to get the x-intercept. So the x-intercept is 3. Now, it would be probably neater to do the coordinates rather than just the points. It doesn't matter really, but let's do coordinates. That's 0 and -6. And then you just do a straight line through that. Okay, I think I've got a line here somewhere I can use. Okay, let's make that a different color then. Red.
Yes, sir.
There we go. That's the straight line. You're going to give it the arrowheads. Okay, so this is a rough drawing for now, because I'm not sure how big that parabola is. Okay, what the equation of the parabola is g, and that is y equals -2x squared plus 4x plus 6. So I know it's going to go through a y-intercept of 6, but the turning point has a coordinate of what? 1 and 8.
Yes, sir.
1 and 8 is there somewhere. It will go through that side and it'll go through there somewhere. So that's 0 and 6. And the turning point is 1 and 8. Just want to close this bracket here. That we did work out in the previous sum.
Yes, sir.
Because we wrote it in turning. You can also see there that is -1, so it's positive, and that's 8. Good. Now they want indicate all intercepts with the axis and the turning points. Right. So we need to get the x-intercepts of that parabola, and to get that you make y 0.
Yeah.
So I'm going to divide with 2. Then I get 0 equals -x squared plus 2x plus 3. I take everything to the left. Oops, then that becomes a -2x and a -3 equals 0. Then I can factorize that. So x and 3 and x and 1. We haven't done any of these factorizations yet, so I'm assuming that you can do it.
Yeah.
X is 3 or -1. That is not possible. You see my graph now, it's a problem. You see that?
Yes. Yes,
So
sir.
what I'm going to do, because it's still like in pencil, get this away. I'm going to actually move that straight line graph because otherwise it's going to be too narrow. It is difficult to move this line. There we go. And I'm going to move it there. So this is not a freehand drawing. So I'm just going to move that coordinate there. So they both intersect. The drawing has showed me that they both intersect there. Not the drawing, the actual calculations that I've done. Okay, they'll probably want this coordinate soon. Now I can't see if they want it now. Because the question is, draw F and G on the same axis, indicate all intercepts with the axis and the turning point. Now we've done all the intercepts with the axis and we've done the turning point, but I'm going to also get that coordinate where the two lines intersect. How do we do that?
Sir?
How do we get that coordinate there?
That coordinate there.
Yeah. Look, the one place of intersection was 3 and 0.
Yes, sir.
So what's a rule? How do I get any X value where two graphs intersect? That's
Or
like one of
you
those
like you
rules.
make the equations equal to each other.
Very good. So I'm going to take 2x minus 6, which is a straight line, and make it equal to the parabola. I'm not 100% sure if they want this, but I'm just going to do it. So that's 2x squared minus 2x is 0. That's wrong. Oh, I've got a mistake here. That's plus. So that becomes negative 12 is 0. So I divide with 2. And then I factorize that. One of the answers must be 3.
Yes, sir. Positive.
Very good. X is 3 or negative 2. So I know that coordinate there as a negative 2x value. And I'm just going to choose any one of the equations to get the y value. I'm choosing the straight line. So instead of a x, I put in a negative 2. And then I get minus 10. Right, that should cover all those 7 marks. Maybe you want to just finish that?
Yes, sir.
Tell me when you are.
Yes, sir, I'm done.
Good. Okay, everything we've got here is on the graph, so I'm not worried about any of the calculations to save it. Right, now they want to know what is the range of G. G is the blue graph. What is range again? Is that
Range.
is that
Range is
y
the
values?
Y elements.
The
Yes,
y
sir.
elements. Okay, the range is the y elements. Well, the highest y element I've got is 8. So the y values are always smaller or equal than 8, and y is element of real numbers. That's one way of writing it. You could have also written it as follow. You can say y is an element that is not equal to negative infinity, and it's equal to 8. Y element of real. Which one of those two ways of writing do you use?
The second one, sir.
Okay, both are correct. Both, you can use any one of the two. Okay, now, for which values of x will the blue graph or the parabola be larger or equal than 0? Well, I'm going to highlight the area where the graph is larger or equal to 0 with yellow. That is when the graph is on the positive side of the y-axis. They want to know what are all these x values in between. So
Oh, we have
we're starting at -1,
Yeah.
we're ending at 3. So x must be larger or equal than -1 and smaller and equal than 3. X is real numbers. Do you understand what that means? There can be
Yes, sir.
fractions in there as well and irrational numbers. Good. And then give the coordinates of the turning point of the following. Okay, this is 2 marks. They give you this graph. They give you at 1.5, they give you g of x minus 3 plus 2. And they want to know what is the turning point. Okay, let's say TP.
Turning point is 2, sir. It's 0, 2,
Really? What did you do?
I would say. Yes.
I would
So
say
because the
it's
turning
minus
point is
2 and
only
10.
Q.
Look what I'm doing. G of x, or gx, looks like this. -2, x minus 1 squared plus 8. So g
Yes, sir.
of x minus 3 is exactly the same graph, but wherever there's an x, I'm just putting, sorry, it's a plus 2 at the end as well. Let me just dot that out. Start again. They want to know what is the turning point of g of x minus 3 plus 2. So I'm just, everywhere there's an x in the previous graph, I'm just going to write x minus 3. So instead of x, I'm writing x minus 3. Then I have plus 8. And then at the end, I'm also adding 2. So I have minus 2, x minus 4 plus 10. Is that correct? Yes. So the turning point,
Good.
the turning point is 4 and 10. So what the graph did, it moved 3 units to the right and 2 units up.
So
I'm listening?
this one, it's confusing me, sir.
Yeah. Okay, basically it works like this. So for instance, you have gx or fx equals 2x plus 1. And they want to know what is g of x plus 1. That will be just 2 instead of an x, I write x plus 1 plus 1. So what is g of x minus 2 plus 5? Everywhere there's an x, I write x minus 2. And then there's plus 1. And then at the end, I'm adding another 5. Can you see that?
Yes, sir.
Okay. Next question.
If we go back to, I want to write the notes, sir, on
Okay.
1.5. Okay, yeah.
Are you on a laptop?
Sir?
Are you on a computer or a laptop?
Laptop.
So is the screen size fine?
Yes, sir.
Okay.
Yes, sir.
Okay, this is a huge question, number 2. Okay, I have to like paste that in sections. The screen is just going to go black when I paste, copy something. Okay, there we have one section. Just going to make that smaller. Then the graph. Yes. Yeah, this graph isn't drawn like a, there's a lot of questions here, so we're going to do them in parts. Right. We have two graphs, f. F is quarter times 2 to the power of x plus 6. Yo. And I'm going to make it blue. It's this graph here. Right? And then I have gx, which is just a little part of a hyperbola.
Yes, sir.
At least I know the following, that this dotted line here, this one here, is y equals 6. Because that's the, what? It's called,
Horizontal asymptote.
yeah, horizontal asymptote. And b is the vertical asymptote.
Yes, sir.
And that's going to be x equals 4.
Yes.
Good. Right, below shown two graphs, blah, blah, blah. 2.1. fx can also be written that way. Determine the value of p. So what they've done the following. They're not expecting you to know this, but I'm just going to show you the following. This is the graph. Quarter times 2 to the power of x plus 6. So they've taken that quarter and made it 2 to the power of minus 2. Ah.
Yes, yes, sir. Yes, I
2 to the
get.
power of x. Okay, maybe you can just do this calculation. And then because those bases are the same, I can just add the exponents.
X minus x. Sir.
Yeah. Right. Determine the value of p. P is,
Equal to -2.
yeah, because they have a plus there. Therefore, p equals -2. Right. So p equals -2. Good. Write that down because I'm going to delete it.
Yes, sir. Equal to 2x plus 6. Therefore,
Pardon?
p equal to -2. Yes, sir.
Good. I'm just going to make it small then. Now 2.2 we've done. Give the equations of the axis of symmetry of gx. G is that hyperbola. So the one is y equals 6 and the other one is x equals 4 now.
Yes, sir.
Good. Are they axis of symmetry? Yeah.
Sir?
Are those axis of symmetry or asymptotes? Those are asymptotes.
Yes, those are asymptotes.
Why is it only 2 marks for axis of symmetry? Those are not axis of symmetry. Those are asymptotes. Is that correct?
Yes, sir.
So why is it only 2 marks for axis of symmetry? Axis of symmetry is difficult. Okay. Your axis of symmetry looks like this. Y equals x plus c. And the other one is y equals -x plus c. Remember that? Can you remember that from grade 10? When you had a normal hyperbola like that, your axis of symmetry with that one, that is x equals y equals x,
Why?
and that's
Okay.
y equals -x. But now this thing is moved. It moved actually. It moved to this coordinate here, which is 4 and 6. Is that correct?
Yes, sir.
So I'm going to take both of those equations. And I'm going to say, look, it's actually only this one. That's the only axis of symmetry. And that's y equals x plus c. It doesn't have another one. Look, there's a little mistake here on the paper. This green graph, the hyperbola, does have a limit on it. It should say it's true only for x smaller than 4. No,
Yes, sir.
because it only has one leg. Can you see that? It doesn't have 2.
Yes, sir.
So that's a little problem for me because that should have been added there. So it's only this one they're going to use. They're not using the one on the right. And then I'm going to just put the coordinate in 4 and 6. 6 equals 4 plus c. 2 is c. So that coordinate is y equals x plus 2. That's the equation. And that's why they probably have their one or singular use of equation. So this one is not applicable because it doesn't have two sections, it only has one section.
Yeah.
Right, now what is the length of AD? How long is AD? AD is just the difference between the y-intercepts. So I'm going to take both graphs, f, y equals a quarter times 2 to the power of x plus 6. To get the y-intercept, I'm going to make x 0. So that's a quarter times 2 to the power of 0 plus 6. And that will be 6 1/4. And I'm going to take the other graph, which is g, and I'm going to make x0. Y equals 1 over 0 minus 4 plus 6. And that is 6 minus a quarter. So that is 5 3/4. Now,
Yes, sir.
so the difference, therefore, AD equals 6 1/4 minus 5 3/4. Is that 1?
Oh, let me just calculate it.
It's a half. It's only 0.5 units or half unit.
Getting calculated now. Please can I just do this again? I get a half.
Yeah, it's only half. So 0.5 units basically. It's probably a better answer, 0.5 units. I don't know, it's the same. Okay.
Yes, sir.
Right, next question on this. So what I'm going to try and do is just steal that graph. Maybe you can remember a couple of things. Terminal coordinates of f. F is the x-intercept of the graph. And the graph was what? Can't remember. It's G, 2.4. So I need to get that value there, that coordinate there, F. And that is the hyperbola, which I need to make the y value 0 to get the x-intercept. And the equation was something like y, so this is G, y equals 1 over x minus 4 plus 6. So to get the x-intercept, I make the y value 0. Minus 6x minus 4 is 1. Minus 6x plus 24 is 1. Minus 6 equals minus 23, 6x. X is 23 over 6. So F is 23, sorry, over 6 and 0. You happy?
Yes, I am happy.
Coordinates of C. Okay, let's get that graph again. It's F, because it's on this green graph. I can't remember what color we made it. Yellow.
Made it blue, I think.
Okay. So C, we know that value was 4, wasn't it? That is x equals 4. So if they want the coordinates of C, we already know that the X value is 4. We just don't know the Y value.
Yeah.
So we take that graph, which is a quarter. Let's just write it properly.
It's like a quarter X multiplied by, no, it's a quarter multiplied by 2X.
2 to the power of X. Plus 6.
Yes.
So I'm just going to put, to get the Y value, I'm just going to put 4 in instead of the X. And then you put that in your calculator. I think it's 10. Yeah. Y is 10. Nice.
Yeah.
Right. Give the equation of hx if h is the graph of gx reflected in the y-axis.
So,
Okay, let me just get this out of the way. So I have space to write. Okay, let's get G again. So HX is a new graph, and that's the reflection of GX in the y-axis. Now G is that yellow graph.
so
So it's going to reflect over. What does that mean?
reflect over.
It's all
That
my
means
y
it-
values are going to change sign.
Yes, sir.
Okay, so let's just get this G again. G of X equals 1 over X minus 4 plus 6. So if that whole graph reflects over the y-axis, the y values changes. So you can do this. G is y equals 1 over X minus 4 plus 6. Therefore, H is minus y, because the y values change sign. If they reflect over the y-axis, all the positive values become negative, and all the negative values become positive.
Yes, sir.
And now I'll just multiply with a 1 minus 1 right through. Then it's y equals minus 1 over X minus 4 minus 6. And there's the graph. And then you write it like this. Gx equals minus 1 over X minus 4 minus 6. Am I allowed to do this now? All of the sums?
Yes, sir.
Okay. You can't get 100% for this tutorial then. Okay, I'm going to leave something out then. Okay. 2.7. The points M, which is 1 and y, and N, which is X and 7, is on F. So it's on that exponential graph. It's on
Sir?
y equals a quarter times 2 to the power of X plus 6. It's on that graph. F.
Yes, sir.
They want to know what is the average gradient, 5 marks. Well, average gradient is just
Actually,
y2 minus y1 over x2 minus x1. That's gradient.
yeah.
Problem is, I need that y value and I need that x value. So I'm going to take the graph to get m. I'm just going to put 1 into x's place. Y equals a quarter times 2 to the power of 1 because x is 1 plus 6. And that is 6.5. Really?
Sir.
Is it
Answer.
6.5? 6,5. I'm going to use 6,5. So that's 2 times a quarter, it's a half, plus 6, and that's 6,5. This is ugly. And then I'm going to take n and put x and 7 in that. We're using the wrong graph, are we? No, we are using the right graph, the blue
No,
one.
we're not.
Y equals, and then instead of a y, I'm going to write a 7. And that is a quarter times 2 to the power of x plus 6. Throw the 6 over, I get 1 equals a quarter times 2 to the power of x. Divide the quarter away, I get 4 equals 2 to the power of x, and therefore x is 2. So my m coordinate is therefore 1 and 6,5, and my n coordinate is 2 and 7. These are the two coordinates, and now I'm just going to use them, or those coordinates, to get the gradient. The gradient is one y value. Let's take the bottom one first. 7 minus the top, which is 6,5, and then we use the bottom n x value minus the top x value, which is 1. I get a half over 1, which is half. The average gradient is a half. This is actually a huge sum, and it's 5 marks.
Imagine. So,
But you would be able to do this.
yes, I would.
Nice. Do you want to jot it down?
Sir,
Do you want to write it down?
I'm done writing it down.
Okay, good. Next question. We are finished with this question, and there's only one left. Why does it look the same? It's not the same. There are two graphs again. We have a parabola and also exponential graph. And we, for 8 marks, have to draw them on the same set of axes. Yes, it's a lot of marks for drawing in this paper. Which one do you want to draw first?
Can you please draw down the parabola first, then you can do the exponential.
So 3.1, f is the graph y equals negative x squared minus 2x plus 3. Okay, it's a sad face, so it's going to look like that. What are we going to do first? Get the turning point.
Yes, sir.
The turning point x value is minus b over 2a.
B over 2 over 8. Yes,
So that's negative 2 over 2 times 1, and that's just 1.
which equals to 1. Yes, sir.
So the x value there is 1. And then I substitute 1 back into the equation. Therefore, y equals negative 1 squared minus 2 times 1 plus 3. That's funny. That's 0. Really?
Okay, this equals to 1.
Can't be 0.
Yes, it is 0.
It's not possible. Because then we don't have a y-intercept. Oh, I have a small mistake. Small mistake. So look, we can't, the graph can't move down onto the x-axis, because then it won't have a y-intercept of 3. So this is my mistake. I left out a minus there.
Wait.
Because the b value, the a value isn't 1, it's minus 1.
Oh, yes, sir.
So that becomes negative 1. You see that?
Oh, yes, sir. Yes, sir.
So that graph is wrong. And then I substitute
then
negative 1 in
the y
there.
value is 4.
I get 4.
Yes, sir.
Okay, so let's just change this graph. It's wrong. You see, graphs are nice. When you make a small mistake, it actually tells you. I'm just going to redraw that graph. It's difficult to connect points. It's easier just to redraw it. The graph shows you visually that you can't do what you're doing. You can't have that value. So that's -1 and 4. And this intercept was 3. Okay, there we go. That's the one drawn.
Yes, sir.
And then the other one is G. And that, let's just do it here. G is y equals -2 times 2 to the power of x minus 1 plus 1. Yes. So we have a asymptote here of y equals 1. I can
Yes,
get
sir.
the y-intercept by making x 0. So the y-intercept is -2 times 2 to the power of 0 minus 1 plus 1. And that you can put in your calculator.
Okay. I get 0.
Yep. So now this value here, this 2 here, tells you that the graph looks like this. We can test that. I'm not sure if they intersect here. So I need to put a coordinate there of 0 and 0. And then I'm going to just put another value in. Look, I haven't done the x-axis here.
Okay.
We haven't done that yet. Let's factorize that before we continue, because I don't know if the red graph is going to intersect with that black one.
Yes, sir.
So let's just finish this first. G of x is y equals -2 times 2 to the power of x minus 1 plus 1. And I'm just going to put a y value, x value in of 0 to get the y-intercept. Y
Yes,
equals
sir.
-2, 2 times 0 minus 1 plus 1. Oh, we've done that. And that is 0. So we have 0 and 0 for G. Okay, let's just
Correct.
finish off that x-axis because they're gonna ask, they're gonna mark these two x-intercepts as well. So I make y 0 minus x squared minus 2x plus 3. X squared plus 2x minus 3 is 0. That's easy factorization. X 3 1 plus minus x is 1 or -3. Good. Those are all marks. So now what I can do, look what I'm doing now. Now I'm going to put in an x value of 2 there on that exponential graph. So the exponential graph is y equals -2 times 2 to the power of x minus 1 plus 1. I'm putting in an x value of 2. Why? I need another coordinate on that graph. Graph can't only have one coordinate. So I'm putting x equals 2 in that graph. So y equals -2, 2, 2 minus 1 plus 1. And then I get -3. So that is 2 and -3. That just helps me to see that those graphs will intersect.
Yes, sir.
You can't determine this value, eh? That intersection value you can't determine. Okay, get that down.
Yes, sir. Yes, sir.
Right, cool.
Sir.
Yes. Done.
Two down.
3.3. 3.3. What is the range of f? F is the parabola. Okay, you're going to write it in your way. Range is y values.
We
Y
haven't
is an
done
element.
3.2.
Pardon?
We haven't done 3.2.
Oh, axis of symmetry of f. It is x equals 1, negative 1. Is that correct?
Axis of
Why? That is a
Mhm.
symmetry axis for that parabola.
Oh, yes, sir. -1 there.
Remember, it's f, not g.
Yes, sir.
And then the range of that blue graph is the y values. Y is an element, it does not include or reach negative infinity, but it includes 4, and it's real. And then 3.4, what is the range of g of the red graph? Well, the red graph is always lower than 1. So the
Yes, sir.
y values are element of, it does not include negative infinity, and it also does not include 1. Is that correct?
Yes, sir.
Jeez, it's becoming small now. Okay, now 2 marks for 3.5, which is like a, I can't really explain that. What is determine the value of f0 minus g0? Well, f0 is 3 and g0 is 0.
Yes, sir.
So the difference is 3 units.
It's 2 years.
Yeah, but it's 2 marks. So they might want you to do this for 2 marks. I can't see how they can give you 2 marks. They can, I can do this. f0 equals minus x0, which is now 0 squared, minus 2 times 0 plus 3, and that is 3. And g0 is, well, we've done that actually, so I don't know why we can do it again. 0, and therefore 3 units. Do you understand?
Yes, sir.
Why 2 marks? You must make a decision. Either way, you're going to write 3 units, or you're going to do the calculations and show them how you got 3.
Do the calculation, sir.
Okay, do the calculation. Then you have to also do this calculation, eh?
Yes, sir.
And then 3.6. I just want to do that on a new page, because I can't even see what I'm doing here. My screen is definitely smaller than yours. What is the value of k where that equation, minus x squared minus 2x plus k equals 0, has no real roots? You can see that from the graph, basically. You just move the graph down until you don't have any roots anymore. So I tell you now that k is probably smaller than -4, or you can do it algebraically, where delta equals b squared minus 4ac. Remember this?
Yes, sir.
-2 squared minus 4 times a times k. So delta is 4 plus 4k. Therefore, 4 plus 4k must be smaller than 0, because if delta is smaller than 0, we don't have any real roots. So 4k is smaller than -4. K is smaller than -1. That's quite interesting. B squared minus 4ac. Something tells me this doesn't make sense. Let me look at that equation again. Smaller than -1. OK is the y-intercept.
Yeah.
I don't agree with this. Oh, because we made a mistake again. This is a huge mistake. Sorry about this. It doesn't make sense. You can't just make it. It doesn't make sense. We made a small mistake here. We didn't follow the steps.
But delta must be always.
Now we made a small mistake. It's for AC. Now look at this. Oh, it's a different graph. It's a different graph. Yeah. Okay, now it's fine. It's correct. It's correct.
Yes, sir.
I was missing in my head. I was missing that +3 there, but I didn't have it there. So therefore, 4 plus 4k must be smaller than 0. 4k must be smaller than -4. K must be smaller than -1. That's the answer. Right. Okay, I understand. I just thought we can do it graphically, but these are not the same graphs. The bottom one here doesn't have that +3 in, so it's already moved 3 units down. So I need to just move it further than -1. Then it won't. Then the turning point won't touch the x-axis. So they were drawing this graph, and this height here was only 1 unit, and that y-intercept there was 0. So if I move it down, the y-intercept to lower than -1, then that turning point, that the graph won't touch the x-axis anymore, and then we'll have no roots.
Yes,
But you can do it algebraically like this. It's just easier. That's it. Good, sir.
Thank you, sir. And sir,
Next week, sir, could we please do like the average gradient on like this thing on, because I was busy with it this week and it's a little bit tricky.
Average gradient is just normal gradient. It's no difference. You just need to get 2 coordinates, and you do y minus y over x minus x. But if you get me example and you send it to me, then we do it.
just take a picture.
So I can give you a graph.
Yes, sir.
Let's just use this last couple of minutes to do that. So for instance, I have this graph now. It was y equals -x squared. What was this? Minus 2x plus 3. It looked like this. Remember?
Yes, sir.
Okay. Now, okay, let's use that coordinate as, say for instance, A. So that was -1 and 4. And let's say B was here, B. And that was 1 and 0. The average gradient between A and B is just y2 minus y1 over x2 minus x1. So basically, you just take a straight line, you draw it between those 2 coordinates, and then you get the gradient of the straight line. It's only in grade 12 that you do tangents, which only touches a curve at one point. So you only have normal gradients. So I'm using the top y value as the first one, or the second one, minus the bottom y value. The top x value minus the bottom one. And then I get 4 over -2, and that gradient is -2. They could have skipped. They could have said, okay, let's do the average gradient between A and D, and they give you x value there of -3, and they skip the y value. Then all you do is you can put the -3 value into the equation. You get the y value, and then you take that y value, and then you do the average gradient between those 2 points. So you can always find the missing coordinate if you have the equation. It's just something. It's important. You have to be able to do it, but there's nothing difficult to. It's just
So the average gradient is the same as normal gradient.
Normal gradient. They have to say average gradient because later on we're going to work with something called tangents. Or you can call it a specific gradient or a gradient at a specific point. You were just working here with average gradients. Remember, this parabola, the gradient changes all the time. from D all the way to A, it's got a positive gradient, but from A to B, it's got a negative gradient. So the gradient is changing all the time on the curve. So that's why we have to use average gradient between certain points, because between D and A or between B and A, the gradient will change all the time. Because it's slow.
Yeah, so
Good. I'll see you next week.
yes, sir. Bye.
Bye-bye time.